For 6.4, we're just going to talk about general transformations, and we touched on this a little bit last class. Like whenever I talked about what the parent functions were and just kind of the ones we've learned so far. So today we are going to talk about all of the parent functions. And so I'm going to write at the top, parent functions. Whoa. There we go. Parent functions. And I am going to say that you do need to memorize or know these and what they look like without a calculator. So this lesson is kind of like you need to memorize what the parent functions look like and then be able to graph them based on the transformations. So we've learned in depth 3 of them. Y equals x squared, absolute value of x, and x. So let's sketch those really quickly. X squared has a vertex of 0, 0. Up 1 over 1 on each side makes a u. Absolute value of x, we just did that last class. Vertex of 0, 0. Up 1 over 1 on each side makes a v. So u, v, and then y equals x is just a line. Up 1 over 1 goes all the way out in both directions. So we have a quadratic, absolute value, and then the parent function of just a line. Those are the 3 we've really talked about in depth. The next ones we're going to learn we have not necessarily done, but I'm going to show you what the graph looks like, and then we can memorize or learn those graphs based on what the picture looks like. So what I want you to do is I want you to pause the video after I give the instructions, and I want you to take this equation, so y equals the square root of x, and I want you to plug in these 4 values and get an answer. So plug in square root of 0, square root of 1, square root of 4, square root of negative 1. And from there, I want you to try and graph. Now, with the negative, remember you can't take the square root of a negative number, it becomes imaginary. And we don't graph imaginary things. So we'll just say no solution or no. And then I want you to plot those points. Once you're done with that, I want you to match your picture to what I got, okay? So pause the video and try that. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and like I said, it's not possible to take the square root of negative 1 because it becomes imaginary, and we do not graph imaginary. So when you plot the points, here's what they look like. Now you notice it starts in 0, 0. The reason why it does not extend anywhere in this region, like anything to the left of 0, is because that would all be imaginary. You can't take the square root of negative numbers. So thinking about y equals the square root of x, it will start at x equals 0 and then go to the right. So in memorizing this picture, it starts at 0, 0 and kind of extends to the right. And you can check this on your calculator just to look at it. But I do want you to memorize the picture. So think about 0, 0, 1, 1, 4, 2, and it always starting at 0, 0. That's kind of like if I were to say draw this on a test or a quiz, just the parent function of it, I would be looking for 0, 0, it pointing to the right and kind of curving up and over. Like it's like jumping over a hill, essentially. And it's still getting higher and higher. Okay, trying the same thing, do that with x cubed. So I want you to plug in these x values, pause the video, and then try to graph it. Okay, so we have 0, 1, 1, 8. Now, if I did negative 2, negative 2 cubed is negative 8, so I could even put 1 down here. It kind of makes a little sideways S. this is what a cubic function looks like. So it's got a point at, like a midpoint at 0, 0, curves up and to the right, down and to the left. Okay, try the last one. Plug these values in. This is called a rational. So if I were to label these, square root, cubic, and then rational. These are the parent functions of them. So go ahead and plug those numbers in, and then I want you to try and graph these. And this one might be a little bit different, so I just want you to try plugging in the numbers and graphing to the best of your ability, and then I'll talk about it. Okay, so 1 over 0, that's not possible. You can't have 0 on the denominator. 1 over 1/2. If you have anything over a fraction, like a fraction over a fraction, remember you take the second one, flip and multiply. So I flipped the 1/2, became 1 times 2 over 1. It's just 2. 1 over 1 is 1. 1 over 4 is 1/4. So let's try graphing those. So I've got the point 1/2, 2. Got a dot here. 1, 1. And then 4 and 1/4. Right here. So this kind of makes a little curve that goes like this. I'm going to redraw that because it does not cross the X or Y axis if you were to put this in the calculator. Now, I want you to think about the negative components of these. So if I put a negative on all of these, that would just make my Y values negative as well. So think about plotting the mirror image of those. So negative 1/2, negative 2, negative 1, negative 1, negative 4, negative 1/4. Does the same kind of thing. If you want to put this in your calculator, just kind of see what it looks like. Maybe you don't trust my picture, just to kind of see, or maybe put it in Desmos because you're on your laptop right now watching the video. Just kind of look at it. So what you'll notice is these graphs, it looks like they're kind of bouncing off each other. They actually don't ever touch the X or Y axis. They get really, really, really close, but they don't touch them. And later on this semester, we'll actually talk about this graph in detail. We'll do a whole unit on it, and we'll call them asymptotes. But for now, just kind of know they look like they're mirror images of each other diagonally, and they don't ever touch the X or Y axis. And then once we get into more transformations, we'll see it shifting up, down, left, right, and flipping. But this is the parent function of it. So I do want you to memorize it. So for this lesson, we now have 6 parent functions that we're responsible for. So if we're going through all of them, right now we have the parabola, the line, the absolute value. Those were the first 3. Now we have square root, cube, and rational. And I usually will call it a cubic, or a cubic function. So maybe you want to fix that. Cube, cubic, same thing. These are the 6 parent functions that you do need to memorize the parent function of them. Now we're going to look at how we can transform those. So looking at how they shift left, right, up, down, flip, and the slope. So if you have like a constant or a number that is outside the parentheses, so outside, that is going to shift it up or down. And remember that if it's outside the parentheses, you keep the sign, meaning like plus is up and minus is down. If it is inside the parentheses, so it's next to the x, that's going to shift it left or right. And it's always the opposite sign. And so that means that if it's a plus sign, then it goes left. If it's a minus sign, it goes right. You guys know this. You've done it a lot. I just want to remind you. If you have a negative out in front, that means that it flips across the x-axis. And if you have a number in front, we call that A, then that is your technical slope. So you go up or down that unit, that number, and over 1. So let's look at taking our parent functions and now applying those transformations to them. So A, B, and C, parent function, y equals the square root of x. If you need to refer back to the original picture, you can. But I have 0, 0, 1, 1, and it just kind of shifts to the right. I am not going to be very picky about individual points. So I do not need you to go and plug in a bunch of values. I'm just looking for 2 of them, and that is the slope, okay? So you're going to plot your original, which is 0, 0, and then your slope, which is 1, up 1, over 1. From there, finish your picture. So I want the graph to look similar, but I'm only going to be grading 2 points, and then obviously like what direction it goes in. And does the graph look similar to its original form? So looking at B, I now have a slope of 1. It goes right 2, up 1. So I'm going to start at 0, 0. I'm going to go right 2, and I'm going to go up 1. So now here is my point. And my slope is 1. So I'm going to go up 1, over 1, shifts to the right. Okay, looking at C, we notice that it flips the x-axis and it goes up 3. When you are doing transformations, always flip first, which you wouldn't think makes a big deal, but it can change the way your picture looks if you flip last. So I'm going to put a little note here, flip first. I'm going to draw 3 things for you. The final answer is, so maybe your brain thinks I'm just going to go to the final answer, but I kind of visually want to talk you through what it looks like to flip this kind of graph. So in its original form, I'm just going to draw the original parent function. It looks something like that, correct? I've got the 0, 0, the 1, 1. If I were to just flip the x-axis, so here's my x-axis. If I were to just flip it, here is what my new function would look like. Whoa, that did not mean to happen. So you can kind of notice that it's now a mirror image across the x-axis. From here, I'm now going to go up 3. So 1, 2, 3. And I'm going to draw the exact picture of my blue dashed line. So down 1, over 1. It now curves downward. So that's my final answer. You do not need these dashes. Like, I was just kind of trying to take you through each step of what I'm doing in my head. You can go straight to the picture, and that's perfectly fine. In fact, I encourage you to just go straight to the final picture. But in my head, that's what I'm doing. I'm starting with the original, which is at 0, 0. I'm flipping it, and then I'm moving it up. Okay, next one, we have a slope of 2, but it doesn't transform left, right, up, or down any. So I'm going to start at 0, 0. But now my slope is 2, so that means I'm going to go up 2 over 1. It just looks a little bit steeper, okay? So the 2 points that I would be grading would be these 2. All right, let's look at the next one. We've got the parent function of x cubed. I am always going to start at 0, 0. So maybe you want to say like that's my starting point. It's the same with your with the square root function. So maybe back at a, my starting point is at 0, 0 as well. So I'm going to start at 0, 0, up 1 over 1, down 1 over 1. So the cubic function, I'm going to be grading 3 points, as in like going to the right one, going to the left one by your slope. Then connect the dots. It kind of looks like a sideways S, like I said. Now if we look at F, I am shifting left 1, down 3. So I'm going to start at 0, 0. I'm going to go left 1, down 3. So here is my new dot. The slope is exactly the same, so I'm going to put a dot here and here. It didn't flip or anything like that, so it still looks like a sideways S where it's going up and to the right, down and to the left. And again, these are the 3 points that I would be grading. Now with G, I am now flipping the x-axis. So originally, where I would have, now I'm going to do my little dashed line thing again just to kind of give you a visual. Originally, I would have something, I'm going to do dashed actually, something like that. When I am flipping the x-axis, it's like I'm literally taking like a spatula and I'm flipping it like a pancake. I'm flipping it over. And so to flip the x-axis for a cubic, it now just changes directions to where it looks like this. I guess I can color that in. So now my dots just changed directions. They got reflected over the x-axis. So you can kind of see I just flipped it over. I rotated it 180 degrees. So that's what it looks like to flip. It now just changes direction. So it goes down and to the right, up and to the left, and my 3 points that I'm now grading, those points have now reflected the x-axis. With H, I have 2 transformations. I'm going right 1, and I have a slope of 3. So I start at 0, 0, and I'm going to go right 1. So here's my new dot. A slope of 3. I'm going to go in both directions. So up 3 over 1, down 3 over 1. And I did not flip the x-axis or anything. So I just connect my dots. It looks a little bit skinnier, like it squeezed it in. Okay, next one is 1 over x. We call that rational. Remember? So when I'm looking at these, the 2 points I'm going to be looking at before transformations, like the actual parent function, are going to be at 1, 1 and -1, -1. And remember that it makes, like it just lines the axes, gets really, really close, doesn't touch. And I have these asymptotes along the x-axis, like this. And I actually want you to add those dashed lines in. So go ahead and add those in right now. Those are my asymptotes, meaning my function does not ever touch them. So what I would be grading would be these 2 points. I want you to add the dashed lines. And then your function is lining those on either side, but not touching them. Now, if I were to just flip it, so that's all that J is doing, is it's flipping the x-axis. Imagine taking that pancake spatula, reflecting it. All that's happening is now my 2 dots reflect the x-axis. So the one that was here now jumps down, and the one that was here now jumps up. The graph looks exactly the same, but it got reflected. And then I have my dashed lines still in the same spot. So I'm going to add those in. Okay, so for the next one, let's talk about K. The only transformation is it looks exactly like the original, but it is going down 2 units. So imagine shifting. So we've got our 2 dots. Imagine shifting those down 2. So here and here. Another kind of way to, I'm going to be grading like these 2 dots right here. But another way to think about it is that your dashed lines are always connected, or they start out at 0, 0. Like the intersection of your asymptotes. So if you think about it that way, my intersection of my asymptotes now shifts down 2. I've got dashed lines in either direction. So whenever I'm graphing these, that's kind of how I think about it, is there's no actual point at 0, 0, but that's where the intersection of my asymptotes are. And so it's easier for me to transform those and then put the 2 dots on either side. And then it looks identical, just shifted down 2. Okay, the next one, transformation would be right 1, up 1. So if you think about starting at 0, 0, I'm going to go right 1, up 1, and here are the intersection of my asymptotes. Then I'm going to put dashed lines on either side, so in both directions. Dot, dot. They're going to outline, curve your asymptotes, just like that. And then lastly, M through O, I would hope you could do these on your own, but just to refresh our brain, the line starts at 0, 0, up 1 over 1. Transformation is down 2, up 1 over 1. Transformation is down 1, slope of 2, up 2 over 1, up 2 over 1. So for your homework for this, it's going to look very similar to the notes. I'm just going to ask you about the 6 parent functions and their transformations. Go really slowly on them. Remember your starting points. Like you're going to start at 0, 0 for all of them, essentially. And go left, right, up, down, slope, flip the x-axis. Remember to flip first. And then check the answer key, and you will submit that to as a PDF on Canvas. I hope everybody's having a good week. I miss you guys. Probably doing something fun in Hawaii right now. Or I could be sleeping. I don't really know the time difference. But I hope you'll have a great day. And I look forward to seeing you guys when I get back.